Hello everyone, my name is Nick and I'm going to be kicking us off with our presentation. Our group is called Thinking Canoe, starring our boat, the Unsinkable 2. Beginning with IDing the need, we were tasked with creating a canoe formed with concrete that could float while holding the weight of marbles. Moving on to the constraints and criteria, the canoe had to fit within a box that was 18 inches in length, 6 inches in width, and 5 inches in height. We were also prohibited from using Quikrete or any moldable concrete. The canoe must have a smooth exterior finish made up with a V-shaped bow, stern, and cross section, with all materials for the project kept under a budget of $40. We then searched for solutions, keeping in mind that we needed a mixture containing a lightweight aggregate to keep it less dense than water. We also needed a mold that was strong enough to hold the concrete in place, but also flexible enough to be pulled apart to remove the canoe. We then analyzed our potential solutions. We researched that styrofoam was a good lightweight aggregate that could be held up in water and also float. We also considered a few different mold options, including clay, 3D printed, and styrofoam blocks.
My name is Griffin, and today I'll be talking about what we picked as our final design. We decided that the final dimensions of our boat would be 16 inches by 5 inches by 4 inches, and that we use styrofoam pellets as our aggregate. To create our mold, we used styrofoam blocks and cut them up so that we could fit the boat in there, and that we would use for our ratio of concrete 1 to 1 to 2 with respect to sand, cement, and the styrofoam aggregate. After picking what we believed to be the best design, we created a detailed drawing of our final plan to work off of, and then we modified some of our dimensions later on in order to make it fit into the styrofoam blocks. We then talked to some of the mentors in the engineering village and an RA who had previously completed this project to get their thoughts on our design. We received a few pointers from them that we used to make changes to our final design.
What's up, guys? My name is Jake, and I'm going to start my section talking about the construct solution phase. We started by securing the styrofoam molds together and wrapping them in plastic for the concrete mix. In our bucket, we mixed the ingredients and ended up with a new mix. We poured the mix into the mold, and for 24 hours, we let it set. Then, we removed the canoe from the outside mold, chipped out the inside mold, and ripped off the plastic wrap. So when we took our canoe out of the mold, we tested it and saw that it was close to being able to float, but just couldn't. We used a Dremel tool to carve out the inside of the canoe and make the walls a bit thinner. We also cut along the sides and top edges, giving us a good shape. When we tested again, we found that the canoe could indeed float. So some challenges we faced. Well, first off, making the canoe lighter was hard because we had to be very meticulous when cutting the concrete walls. Staying within the constraints was difficult because our dimensions mattered and their proportion also mattered for good floating ability. Getting the concrete mix to the right consistency and setting it was hard as well. To address the weight, we used a ratio consisting of mainly lightweight aggregate, and as I said before, cut excess weight off. We helped the concrete set without cracking by misting the canoe with water. We also changed the ratio to make the concrete a better consistency and for more strength, as we started with a 1 to 1 to 2 ratio and ended up with a 3 to 3 to 4 ratio. We were very careful also to measure everything to stay within the qualified guidelines.
Hey guys, my name is Chris and I'll be talking about Fed Day. During the competition, our canoe was able to hold about a pound of marbles before sinking. We believe our project was a success because it was able to hold the weight while meeting all criteria and constraints for the project. Alright, so what didn't work? Well, since our canoe was not as large as some of the other canoes that were made, our canoe was only able to hold about a fraction of some of the weights that the other canoes held. The smaller size also decreased the amount of water that was displaced, which is why it could only hold so little weight. Another problem that we experienced during this design process was the amount of concrete that was still on the canoe after it came out of the mold. Due to all of the excess weight, our canoe could not float on its own in the water unless it was sanded down. So after completing our Fed project, we have some advice we'd like to share with the upcoming freshmen. Firstly, scale matters. When designing your canoe, try to maximize the volume that the canoe can hold so that it can hold the weight of more marbles. Secondly, start early. Concrete takes at least 24 hours to dry completely, and if groups want to cycle through multiple prototypes to find the best design, they will need to begin building before the weekend before Fed Day. Next, take lots of pictures. You want to be able to document and show your progress throughout the course of the semester. Use pictures to show how hard you have worked to get to your final product. Lastly, work on your presentation skills. As an engineer, you will be constantly trying to solve problems, and having good presentation skills will help you to get your points across to your peers, as well as help you during interviews in the future. Lastly, here are our citations for our research. Thank you so much for watching our video, and we hope you guys have a wonderful winter break.